Hello everyone. Let's start with an interesting thought. Have you ever wondered why Earth feels just right for life, not freezing like Mars or boiling like Venus? The secret lies in a natural process we call the greenhouse effect. The sun sends energy to us mostly in the form of shortwave visible light. Part of this energy warms our surface, while some is reflected back into space. Now, here's the twist. Gases like carbon dioxide, methane, and water vapor trap the outgoing infrared heat. They act like a blanket, keeping Earth's temperature around a comfortable 15 degrees Celsius. Without this effect, our planet would chill at nearly minus 18 degrees Celsius. As you can see in the diagram, some rays bounce back, while others are trapped, creating the cozy atmosphere we live in. Now, which gases actually perform this role? The main culprit, or should I say savior, is carbon dioxide. It absorbs infrared radiation and stops it from escaping to space. Methane and nitrous oxide are even more powerful heat trappers, though they are less abundant. Water vapor plays a special role too, working like an amplifier. The warmer the air, the more water vapor it holds, and the stronger the greenhouse effect becomes. Here's the catch. Due to industrialization and deforestation, carbon dioxide has now risen beyond 420 parts per million, far higher than in pre-industrial times. If you look at the comparison chart, you'll see just how strongly each gas contributes to heating. Human activity has turned a natural blessing into a growing concern. Let's connect this to physics. Any hot object, including Earth, radiates heat according to the Stefan-Boltzmann law, Q equals sigma into A into T to the power 4. Here, sigma is Stefan's constant, A is surface area, and T is temperature. The Earth emits infrared radiation as it cools. Greenhouse gases absorb specific infrared wavelengths, then re-emit them in all directions, including back towards Earth's surface. That means some of the heat we should lose is returned, increasing the downward heat flux. Over time, this imbalance causes Earth's average temperature to rise. It's like having an extra layer of glass in a greenhouse. So, what happens when this balance tips too far? We call it global warming. Since industrialization, our average temperature has risen by about 1.1 degrees Celsius. It may sound small, but it's enough to melt polar ice, raise sea levels, and intensify floods, droughts, and cyclones. Look at the world map. You'll see the red zones of drought, the blue areas of flooding, and the white polar regions melting away. Species lose their habitats, coral reefs bleach, and entire ecosystems shift. That's the heavy cost of excess greenhouse gases. But here's the hopeful part, we can still act. The first step is cutting down fossil fuel use and switching to renewable energy like solar and wind. Planting forests is another natural solution since trees absorb carbon dioxide. Even at home, using energy-efficient appliances reduces wasteful emissions. At a global level, we have agreements like the Kyoto Protocol and the Paris Agreement, commitments by nations to keep warming below dangerous levels. The flowchart shows clearly, human activity produces gases, but thoughtful choices can reduce them. The equation is simple, less wasteful energy, fewer greenhouse gases. So, to sum it all up, greenhouse gases like carbon dioxide, methane, and water vapor act as Earth's thermostat, trapping heat and maintaining a habitable temperature. But human actions are intensifying this effect, tipping the balance towards dangerous warming. The physics is clear, the imbalance in radiation leads to climate change. The choice is also clear, sustainable practices and renewable energy must become our way forward. I hope this session helped you see the greenhouse effect not just as a textbook topic, but as a living phenomenon shaping our climate. Remember, It's a balance we cannot afford to upset. See you in the next lesson, where we'll explore another fascinating concept of physics.